Hello everyone, welcome to today's class. Today we have this nice exponential challenge before us here. The question is 5 to the power of minus 1 times 5 to the power of 3k equal to our 3 times 3 to the power of 3k. What is the value of k that will satisfy this exponential challenge? Oh, so without wasting time, we take our solution straightforward. All right, this is 0. Let's go rather. Okay, so now look at this here. First we're going to do here is to rewrite this power here. Okay, so this quantity, which is the first one, according to the law of indices, we see that when you have your a all raised to the power of minus your m, which is equal to your 1 all over your a all raised to the power of m. Okay, so we can rewrite this expression here now. So let's go ahead and write it. This is simply as 1 all over 5 times our 5 to the power of 3k equal to, here we have our 3 times our 3 to the power of 3k. All right. Now the dot here means multiplication. Okay. So don't mistake that for a decimal point. Okay. Now we have to eliminate this 5 here and we multiply through by 5. We're going to multiply this side by 5, multiply this side by 5. So we have here 1 all over 5 times 5 to the power of 3k times our 5 is equal to our 3.3 to the power of 3k also times 5. So what happened? This will go with this. So now left with our 5 to the power of 3k. This is equal to 3 times 5 will give us here our 15. Then times our 3 to the power of 3k. Now you discover the exponent we have on the left-hand side, same thing we have on the right-hand side. But the issue we have here is that we're having 15 attached to this. Okay? If not, they would have applied a simple rule. But here, what we do now, we want to carry all the terms having your 3k at the exponent to the left-hand side. And to do that, we have to divide by 3 to the power of 3k. So yeah, divided through by our 3 to the power of 3k, equally divide this by 3 to the power of 3k. So what happened here? These will go with this because they are the same. Now look at the left-hand side of the equation because they are having the same exponents. What happened? We apply the rule. We say that when you have your a to the power of your m all over b to the power of m, it's the same thing as your a all over your b all raised to the power of your m. If it is true, then what happened? We can rewrite this as our 5 all over 3 all raised to the power of our 3k. This is equal to R15. Easy. Now, so what we do here? It's pretty easy again. We just have to ln both sides of the equation, or we can equally take log to base 10 or to base e. But here, I want to ln both sides of the equation. So it's going to give us ln of our 5 all over 3. So this is ln base e, okay, to the power of 3k, and this is equal to, you're going to have ln of R15. Yeah, 15, right? Good. So we're going to apply a law of logarithm, which says that when you have your ln of, let's take a all to the power of b, then move this back here. So this is going to give us our b times ln of our a. Okay, so we're going to move this exponent back here. So this is going to give us our 3k, okay, that times the ln of our 5 all over 3. Put this in bracket, this is equals to the ln of our 15. All right, so let's continue on this side and see what this gives us. Okay, now let's look at this. We're looking for our k and not 3k ln of 5 all over 3. And again, we can equally split this 15 here, okay? So we can split 15 into 3 times 5. Okay, so we're going to split this, then we now divide through by this. But before then, let's divide through by this expression. So we're going to have 3k times the ln of our 5 all over 3 all over ln of 5 all over 3. This is equal to, we want to split this now, so we have here ln of our 15, which is 3 times 5, bracket, all over our ln of 5 all over 3. Right, so what happened here, and this will leave. So now left with our 3k is equal to, here we are going to apply two rules here. We have the multiplication rule on the top, and we have the division rule below, which is the denominator. So the rule, which says multiplication rule of logarithm, which says that if you have your ln of your take a times b, that this is equal to your ln of a plus the ln of b. Okay, this is multiplication rule, and the division rule says that when you have your ln of your a all over b, so this in bracket is the same thing as the ln of a minus the ln of b. Okay, so we're going to apply these two rules here. Yeah. So we have our 3k will now be equal to ln of our 3 plus the ln of 5, everything all over the ln of 5 and minus the ln of 3. We are looking for 3. So we divide by our 3, we divide the whole of this by 3. This leaves. So now have our k will now be equal to, so if we simplify this expression we have here, this is same thing as our 1 all over 3, okay, into the ln of our 3 plus the ln of our 5, bracket all over the ln of our 5 minus the ln of 3. So this is the lowest form we can simplify this expression here. We can easily get the value of ln of 3 by imputing that in our calculator, and also ln of 5, I equally get the numerical value for that. Then when you simplify this, whatever answer you have from here, multiply it by 1 all over 3, gives you a numerical value that when you impute into the original equation, will give you an approximate value. Okay, so this brings us to the end of this math class. I believe you learned something from this video tutorial. Whatever you must have learned from the video, drop it in the comment section. See you in our next class. Till then, keep winning. Jigs does loves you. Bye for now.